Assalamualaikum, salam sejahtera and salam satu Malaysia to Dr. Najwa and all of my friends. Today, we are from Group 3 are going to present about fast reaction techniques. But before we start our presentation, let me introduce my group members first. Firstly, we have Nurul Ashikin Binti Ramli, me myself, which is Khalidah Binti Talib, Amira Adrina Binti Sabri, Clipina Corelia Anak Calvin, and last but not least is Bethania Ellen Henry. Then, without further ado, let's jump to our presentation.
Hello everyone. So, what is fast reaction? The fast reaction is defined as the reaction which take a shorter time to complete. The fast reaction poses a high rate of reaction. The example of fast reaction are striking a match, burning of petrol in the car engine, and so forth. The fast reaction cannot be measured particularly or by classical technique. Hence, we can use laser technique to record the rate of reaction. There are three types of laser technique which are flow method, flash photolysis, and the last one is reaction method. But in this explanation, my group will focus on flow method. What is flow method? Rapid mixing tools called flow instruments are used to analyze the chemical kinetics of quick reaction in solution. There are two types of flow method which are continuous flow and stop flow. There are different flavors that can be implemented depending on the nature of the reaction as discussed below. For reactions that take place in milliseconds, the standard approach since the 1950s has been to employ a flow technique of some kind. Fast case phase reactions involving a free radical like OH, which can be created by an intense microwave discharge acting on a suitable sources gas mixtures, was first studied using an early example. This gas is created to move through a small tube at a specific speed along with the other reactant under investigation. Stop flow method described below is generally preferred. These methods are by far the most popular for examining quick solution phase interaction over time scale as short as a few hundreds of milliseconds. Even in lab investigation conducted by students, the use of quick simple instrument is now feasible. This method allows for the monitoring of both the accumulation and decay of reaction intermediates as well as change in the concentration of reactants and product. But our topic will focus more on stop flow method, which is our chosen topic is stop flow further transform infrared spectrometric species of glycolic and lactic acids in cosmetic formulation.
So everyone, have you heard about AHA in cosmetic formulation? No? In that case, let me tell you what is AHA. AHA is a hygroscopic salt acid with an alcohol group in position alpha with the atom of carbon of carboxylic function that gives them special properties. AHA, like glycolic acid, is the most widely used in facial cosmetic formulation. Glycolic acid acts as an antioxidant and is believed to reverse the photoaging process by increasing the collagen synthesis in the skin. Lower pH and higher concentration of acid in the cosmetic formulation are thought to be more effective. However, formulation with low pH would cause skin irritation. Therefore, acid formulation are usually partially neutralized by soft bases. Despite the fact that AHA, especially glycolic acid, are widely used in facial cream, there is not yet legislation on its concentration in cosmetic nor analytical methods for the determination of compound. Stop flow process have been proven to be very useful in different instrumental techniques, including Fourier transforms infrared spectrometry. Therefore, stop flow FTIR procedure were used to study the protonation equilibria of glycolic acid and lactic acid. After that, we will go to how the concept applied in this area. Firstly, a stop flow system was used to introduce aqueous solutions of cosmetic samples and standards into the measurement cell of the FTIR spectrometer. Stop flow measurements were made and 25 scans were accumulated. A nominal resolution of 4 cm minus 1 was employed and the IR spectrum was obtained between 4000 and 400 cm minus 1. Then, the background spectrum was recorded previously under identical conditions from a transmitted measurement of the sample cell filled with deionized water, and the most characteristic wave numbers of the species were selected for use in absorbance measurements. Next, the absorbance values of the peaks that measured were taken into account a baseline established for each peak in order to avoid overlapping with other bands. Also, the resolution of the mixtures of the different forms of each AHA was performed by multi-wave number equations that based on Beer's law and the additivity of the absorbances. Two equations were used for each AHA and the calibration equations were obtained from the absorbance of 6 buffered aqueous standards of the AHAs approximately 2.5 mgl-1 and the selected wave numbers of each species. Finally, the concentration of the species were obtained for each AHA by the corresponding equation system.
For the result, the aqueous solution of glycolic and lactic acid have vibrational spectra in the middle IR range with band of their conformational form of different protonation degrees. The most intense bands of the IR spectra of the AHA both are So this is the graph. It shows that IR spectra of aqueous solution of AHA 2% at different pH values, which are for glycolic acid and lactic acid. Now we will see two variation of the use of the FTIR spectra of the alpha hydroxy for speciation purposes. Calibration line at wave numbering providing height differences among absorbance values of the AHA will obtain. To verify the applicability of the FTIR method in analysis of synthetic sample, synthetic cream containing known concentration of the AHA were analyzed by the proposed stock flow method using the corresponding equation. The theoretical concentration corresponding to the different species of each AHA were calculated according to the known concentration of the sample using the protonation constant. That's why stock flow method is very suitable and useful because the total concentration found was accurate for glycolic and lactic acid in all the cases. Next, in analysis of commercial sample, for commercial cosmetic formulation whose total glycolic acid contents were labeled were analyzed by the proposed stock flow method using the corresponding equation system. The theoretical concentration corresponding to the glycolic acid and the glycolate were calculated according to the label total concentration of the samples using the protonation constant. Thus, stock flow method is very suitable and useful when the total of concentration found was similar to the label value in all the cases.
In conclusion, the results obtained indicate the usefulness of the proposed methodology based on the application of Peirce law at two wave numbers using a stock flow FTIR system. The proposed methodology was validated using it to analyze the synthetic samples with different pH and known concentrations. Commercial samples containing glycolic acid were also analyzed by using the proposed method. Species of glycolic and lactic acid can be determined at different pH, and the total content of each AHA can be determined accurately. Hence, the described flow analysis method, which is stock flow method, is very suitable for use in routine controls in the cosmetic industry.
Thank you for watching. Bye everyone.